I'd like to briefly introduce Dr. Colin Foster of the University of Loughborough, who's going to give us today's plenary presentation. Colin's work is very much focused on working with teachers in classrooms designing tasks that give students a more meaningful learning experience in mathematics. In his presentation, Colin is going to give us some insight into the design challenges that he and colleagues have faced in trying to design a completely free, fully resourced, and I think importantly, a coherent research-informed school mathematics curriculum. We look forward to hearing from him. Over to you, Colin.
Hi, I'm Colin Foster, and I'm going to talk about a rather ambitious project that we're trying to do at the moment at Loughborough University. We're just at the early stages of this, but we're interested in trying to design a complete, fully resourced, research-informed maths curriculum for schools. Maybe we're crazy to be doing this, but we're going to have a go. I thought I'd start by saying about how I kind of have ended up here. I've always been interested in designing tasks. I started off as a maths teacher myself and taught in schools for 12 years. And during that time, I designed a lot of tasks and lessons. And I suppose I think of design, educational design at different levels. There's the smallest level of designing an individual task. Then there's designing lessons or lesson sequences. I had the privilege of working with the great Professor Malcolm Swan when I arrived at Nottingham University. And there I sort of moved from designing tasks to designing lessons. We called them lessons, but the lessons for the mathematics assessment project typically took more than what most schools have as a lesson. So they became really lesson sequences. But what I'd never really done is thought about designing a curriculum. I'd always been interested in lessons and tasks, but a curriculum just felt like another step beyond that. And the work that we did at Nottingham was never intended to be a complete curriculum. It was always meant to be enrichment, dietary supplement, you used to call it, things which would enhance what was going on in schools, but not replace a curriculum. And I've always felt that maybe there's an interesting job there to be done, thinking about curriculum design. And so now that I'm at Loughborough University working with colleagues there, we've been thinking about how we might move forward towards designing a complete fully resourced curriculum. So I guess if I reflect on my experience of designing things, maybe a bit unfair, but really I think what I was doing was sort of sitting in a boat all by myself in the middle of a vast ocean with a paper and a pen and coming up with ideas for tasks. And then when I have one that I think is half decent, I sort of put it in a bottle, throw it over the side, and maybe just hope that somebody somewhere might one day fish it out, have a look at it, have some fun with it, and maybe even find a class somewhere that at some point would benefit from doing that task. And it was just sort of a hopeful design where I was just sort of throwing things out and hoping that somebody might find them somewhere and use them. And I think that the danger with designing tasks on their own is that it's not clear how and when anyone might or could use them. And even with lessons and lesson sequences, they're quite difficult perhaps to fit into what's already going on. And so this is really what's got me interested in the challenge of designing at the curriculum level. I mean, there are plenty of challenges with designing individual tasks and lesson sequences, but there are different challenges perhaps when you're working at the level of a curriculum. And so we've set ourselves this challenge to design a school maths curriculum. What do we mean by that? Well, the word curriculum is used in a lot of different ways. Sometimes it means the specification of topics and content that's going to be taught. We're using it in a broader sense than that. So we're saying that we're designing a fully resourced curriculum. In other words, all the materials. So in England, we have a national curriculum that specifies what must be taught, but deliberately doesn't specify when or how things should be taught. And although there might be a lot of common practice across schools in terms of what they teach when, there's actually autonomy that schools have over that. And so what we want to do is produce all the materials for a complete curriculum, fully resourced. We want it to be research informed, and we think that that's something that teachers are increasingly asking for, demanding, that it's not just somebody's best guess of what might be good or just based on one or two people's experience of their own classroom, but something that takes account of the best quality evidence that there is, and not just within maths education, but there's useful research from cognitive science and of course in educational design itself. So we want to take account of that, and we want to design a curriculum that doesn't ignore what is known. It will be completely free, and so the idea is that this is something which would potentially save schools a lot of money, be something that they could use for as long as they wanted, whenever they wanted, and wouldn't cost anybody anything. And we also decided to make it editable. Now, I think that's a little bit of a controversial decision, and I'll talk about that a bit more later. But the idea that if we're going to put something up on a website that's completely free, we might as well do it in a format that means that teachers respects teachers' professionalism, that they can change things around, cut bits out, add bits in, adapt it, even just copy and paste bits of it into their own scheme of work if that's what they would like to do. So we want to make it as useful to teachers as we possibly can by making it editable. And then the final one, and this is the one that's probably given us the most pause for thought, is the idea of a coherent curriculum. We think that some of the curricula that exist out there are not necessarily notable for their coherence. I'll talk about that in a moment, but we've tried to think about what it might mean for a curriculum to be coherent, but also, is that a good thing? Is that something that's a good aim to have? But those are our five intentions for the curriculum. So why do this? What's wrong with what's currently happening? And so I think there's broadly two approaches that schools take, certainly in England, perhaps more broadly, to resource their curriculum. And so the first and perhaps most common option is to adopt a commercial scheme that exists. So that could be a set of textbooks. Increasingly, that either includes an online version or is an online scheme of work. And I think there's a widespread feeling among schools and teachers that these are very expensive and generally of quite low quality. That may be a very sweeping statement to make, but I think that certainly compared with what exists in other countries, maths textbook quality in England is not amazing. And I think there are reasons why we can understand how that happens. Often there are very quick changes to specifications, and publishers have to respond quickly. They are working to tight commercial deadlines and models where they have to produce stuff quickly. It has to look good. And so I think that creates a lot of constraints around what can be done. So teams of authors are sometimes got together quite quickly, and the work is parceled up among them. They don't get a great deal of time for talking and considering the finer issues, but stuff has to be produced quickly. And I think also the design constraints of page design have some negative effects on textbook quality. So the idea that there must be a double page spread and it must have a box this big with that many words in and so on, regardless of the topic, can make it very difficult for authors to produce really high quality material. So if you're doing a geometry topic and you want lots of diagrams, you've still got that constraint perhaps of a double page spread it's all got to fit in there. And so you don't have the flexibility to do what you necessarily would want to do. And the way in which textbook schemes or other commercial schemes are adopted has to be based on a pretty superficial inspection by schools. So somebody comes around and shows off the latest scheme, and there's no time to really look at it very carefully, certainly not trial it with your classes and get really detailed feedback. You have to just have a quick look and think, well, looks quite good. It's got some good gimmicks, perhaps. And so you adopt it. And it might even be that the time spent looking more closely wouldn't be rewarded if all the different publishers are producing very similar kinds of things. The other thing with textbooks, of course, is that once you've bought it, and that's it. Very difficult to adapt them. If you try and do that in your scheme of work and say, when you get to chapter 6, don't use chapter 6, use something else, it can easily get lost or forgotten, and it just becomes cumbersome. And so I think the commercial schemes are not really intended to be used very flexibly. But I suppose the ultimate criticism might be what Malcolm and Hugh have called the authorship model, the idea that somebody drafts something, they and perhaps some others have a quick look at it, make sure it looks okay, and then you publish it. And so it's not really based on any kind of systematic trialing in classrooms to see how it works and what happens. And that's quite a severe criticism. So one approach is the commercial scheme. The other approach that I think is also quite common now is to curate a bespoke scheme of learning. And there are many reasons why that might be a good thing to do. It can be a valuable activity for teachers to come together and talk about curriculum and talk about their teaching and how they go about it. That can often be a really rich conversation. It allows schools to think about their own students and what their needs might be. And so I think the curation model sounds quite attractive, and it's certainly the approach that I took when I was working in schools. But I think it's got increasingly difficult over time. When I was a teacher and sort of amateur task designer, I tried to buy every book that contained tasks for school, and I tried to have an encyclopedic knowledge of maths tasks. And I was probably kidding myself, but I felt that I pretty much knew all the tasks that were out there. And I think it would be impossible for anyone to do that now. The Times Educational Supplement, which is a resource bank of tasks that teachers share with one another, has got 700,000 resources. No one can know all of those. So the Sturgeon's law says that 90% of everything is not very good. That's the polite version of Sturgeon's law. And so there is that murky ocean that I was throwing my tasks into has got bigger and bigger. And it's quite murky and frankly quite a lot of gunk in it. And so teasing out, finding the diamonds among the glass, that's really, really challenging now and very, very time consuming. So I think that that's a huge problem for the curation model. The idea that you can have a sense of everything that's out there and pick out the best from it, I think is quite impractical now. It also might be that the expertise that teachers have, even really great teachers, is not quite the same as the expertise you might need to design a curriculum. So you may be great at planning lessons, you may be great with students and at teaching, you may have great knowledge, but it might not be quite the same knowledge as is needed to put a curriculum together. And of course, teachers are so short of time, and schools are in many cases, desperate for a full complement of maths teachers. And it's just really, really difficult to expect schools to be doing this. And I suppose there's a question about whether it is a good use of time for every school to be reinventing often quite similar wheels. So I guess what we're proposing wouldn't be to try to take anything away from schools or teachers, not to say that you mustn't do this, but to say instead of starting with a blank sheet of paper and trying to put together a curriculum, here's something which we hope is at least pretty good or reasonable. And if you can improve it, that would be great. And so what we hope with the open source approach that we'd be taking is that people can share adaptations of what we've produced. And if you can make it better and you can add things into it and you can change things that don't seem to work, that would just be terrific. Also with the editable affordance, it means that you could produce alternative versions. So if you wanted to do some action research in your school, you could produce two slightly different versions, different in some interesting way, trial them with parallel classes and get your own local knowledge about what seems to be working better among the students that you teach. And so the editable feature does allow a lot of autonomy, I think, compared with an inflexible commercial scheme which can't be edited or changed or adapted. So I think the big problem with the curation that has come up for us has been this idea of coherence, the idea that a collection of great tasks doesn't necessarily mean a great collection of tasks. So you could have a load of tasks which are great in their own right, but that don't fit together very well to make a great collection of tasks, a great curriculum. And so that's worried us quite a lot. And I think it's sort of the nail in the coffin for the curation idea that just bringing together lots of great stuff doesn't necessarily make sense as a coherent whole. So we decided to try and take an approach which, rather than rushing in and putting stuff together and designing things, that we tried to step back a bit and think what would be the principles behind the design of this curriculum. And we've looked at the literature and we've thought and we've discussed and we've tried to get comments from experts on what are the things we should really focus on. Of course, you could make this list of design principles as long as you wanted. And I'm sure that as we develop the project, we'll need finer grained design principles that maybe fit into and among these 5. But our overarching 5 at the moment are the ones that I've put here on this slide. So the idea that we would be working with teachers, not just producing something separately and then dumping it on them. The idea that we would work collaboratively with teachers through our own network here in Loughborough, among schools that we know, so that we have critical friends helping us at every stage, co-designing with us, and most important of all, perhaps, the trialing within their schools. It's quite easy to get expert comment on things, to send drafts to people and say, what do you think of this? And we've got lots of people we can do that with. But what we really value is people who are in the classroom who can try it out and not just tell us what they think of it, but tell us what the students did, what happened when they did this, how did they have to adapt it, what were the sticky points, the things that went wrong, where is more needed, where is less needed, and particularly in developing guidance for teachers that will sit alongside the curriculum. We're really we totally need lots of detailed comments from teachers about how that's working. So we really want to harness the expertise that teachers have and support teachers and work with teachers as we put this together. So that's our sort of number one design principle. We need to take seriously the aims of the national curriculum in England, which are fluency, reasoning and problem solving, and we want to balance those. We want a curriculum that takes problem solving seriously in particular. We notice that in lots of the schemes that exist, sometimes questions are marked or coded as problem solving questions. When we look at them, we don't necessarily see them that way. And so for us, problem solving is about what you doing something when you don't know what to do, about not doing what you've just been taught how to do. And so we're thinking of addressing that in two ways. Within each unit of the curriculum, we want to embed problem-solving questions that are related to that content. But we also want to have standalone problem-solving units that rely only on content from a few years previously. So for year 7 or 8, it might be just relying on primary school content. So that the content isn't what the students are focusing on. They're able to focus on the problem solving strategies that they're using. And so we want to build not just opportunities to do problem solving, but a proper problem solving curriculum that explicitly teaches some of the strategies that will enable kids to be successful with problem solving and makes that a fully integrated part of the curriculum. So that's a really important aspect of the second principle there. And thirdly, we want to give explicit attention to important errors and misconceptions. This is really something I've learnt from Malcolm Swan and his great work on taking seriously what students do and designing tasks that make visible the errors that students might make or the misconceptions that they might hold, and planning to get those into the open, discuss them, and make progress with them. So we really want that to be important. We don't want to skate over difficulties. We want to include things that are examples and non-examples. We want to include tasks that really raise and surface those areas of difficulty. Then number 4, looking at comparing and contrasting alternative methods, not seeing there always being one right way to do things, but recognizing that in mathematics there are frequently alternative methods, and they have different advantages and disadvantages in different circumstances. And so taking all of that seriously, being informed by variation theory and how maths is taught in some high-performing areas of the world. And then finally, this issue about coherence through strategic use of representations and contexts. So rather than thinking of representations as just having them up your sleeve so that you try one, and if a student seems to get on well with that, that's great. And if they don't, you maybe switch to a different one and offer lots and lots of different ways of seeing things at the same time. We're interested in the idea of perhaps introducing representations systematically in a carefully planned order so that they join up and fit together in a gradual way. And I'll say a bit more about that later on, because it's something that we're not completely sure about, and I'd be really grateful for people's thoughts in the discussion afterwards on that. So this issue of coherence we've looked into more and more, and as our theoretical framework, we've taken Leslie Dieterke's work, really nice work, on mathematics curriculum as story. Her conceptual framework, she thinks of a mathematical story as a sequence of ideas with a beginning, middle, and an end, and with elements such as characters, action, setting, and plot. So I'll just leave you to read the quote from her at the bottom of the screen there. So we found this really helpful in our thinking about how we might make sense of coherence across a curriculum. And so there's this idea of story coherence, which is about how things join up and are connected from the point of view of the reader. So it's easy for a maths teacher to think that everything's beautifully connected because we look at one component of the curriculum and we instantly see how it fits with lots of others. But for a student to appreciate that, they perhaps have to make those connections one at a time and begin to gradually see how things are joined up rather than assuming they can just make lots and lots of connections all at once. So we've been thinking about a few things as we try to approach the design. We've not sketched out many lesson sequences yet. We're not trying to start the design of the lesson sequences just yet, but we're trying to sketch out key example lessons and sequences of lessons where we think that there are important decisions that we're going to need to make sooner rather than later. So we've been trying to find situations where we have a real choice, a genuine choice between different approaches to take, and then to design both of them up to a reasonable level of detail so that we can compare them and see what the pros and cons might be. So we're not trying to do that with one that we're sure is great and one that we think is a bit dodgy. We're trying to be really realistic with both so that either of them on their own would look like a sensible approach. And so I'll show you some examples of that in a moment, but it's really at this stage we're thinking a lot about how prescriptive we should be with our design principles that we're laying down and how much we should leave to sort of case by case, and to what extent it's helpful to have principles and to have made general decisions about certain things. So we're building up a list, but we don't want the list to become too constraining, but we want it to be a suitable amount of constraint that will help us to be creative. So here's an example. We've been thinking a bit about negative numbers. And so here's a possible approach, which will be familiar to you, involving negative numbers, taking a number line as a starting point. Now, often people would take a vertical number line and they'd be thinking about temperature and so on. And we've deliberately gone for a horizontal one in order to fit in with the way in which we're using number lines in other chapters. Although eventually students will need to become confident with vertical number lines, because eventually we'll want to put a horizontal number line and a vertical number line together to make a Cartesian plane. So it's not that vertical number lines are bad, but we want to fit in with other chapters where we've looked at perhaps sequences and used number lines for those as well. So it might be that number line is going to be the key representation that we want to use as much as possible throughout the content. But anyway, this is a sketch out of the sort of things we might do with number lines and negative numbers. One way to introduce them is to count back along a number line, fall off the end, and decide that if you want to carry on, it's sort of a choice really, then you better invent some new numbers to the left. And so that's one way of setting that up. And then you can have stuff where you begin to write down equations to show what's going on and do some calculations and then have some discussions and so on. So that's a sort of the level of detail that we're in at the moment. This is all wrong at a fine level of detail, but it's just the rough idea of the sort of thing that you might do if you wanted to introduce negative numbers. So that's model A. Model B would be to start with the sort of matter antimatter kind of approach, where you've got positive and negative particles cancelling each other out. And so one way to introduce that would be to have some pictures like this, and you say, how much has she got in total, and then how else could you make that same total? And so students get the idea of the sort of zero pairs approach, where you've got 1 plus and 1 minus making 0, and you can have as many of those included as you want. And so you could begin that kind of way. And I think, at least at face value, both of those might seem as though they're approaches that you could imagine sensible teachers taking. And so you end up with stuff like this, where when you want to subtract a number that's bigger than the one you've got, so positive 5 take away negative 2, then you need to think about what you need to start with so that you've got the negative 2 there to take away. And so you could do some perhaps quite nice things on that. And I've used these sorts of approaches, both of them, with students in the past. But it might be that one of these fits better with other aspects of the curriculum. And so it might be that even if both of these lessons are perfectly reasonable on their own, it might be that the first one, let's say the one with number lines, makes a better fit, a more coherent fit with other topics and other features of the curriculum, so that even though we might like the counters, we might choose not to use it. And so those are some of the sorts of choices that we're trying to think about. It's not just whether things are good or bad, but whether they fit or don't fit. And part of fit might be things that are complementary. And so it's not necessarily that coherence means a sort of sameness and boring repetitions that every chapter starts with a number line. But we're just trying to figure out what it would mean. And I think that some of the subtleties that we've been getting into are things like this. If I were to ask you to look at these three calculations and put them in order of difficulty, how hard would a student find them to do? I guess you'd have opinions about that. You could get a large number of kids and test them and see how many kids get each of these right. But I think that question makes no sense in the abstract. I think it all depends on how kids are thinking about things like this. So if you're thinking in terms of number lines, then I guess you would say that the one on the right, so this one up here, is going to be the trickiest one, because you've got a double negative, haven't you? So what are you going to do on a number line? Maybe you're going to start at -5. Maybe you're going to face to the left because you're subtracting, but then you're going to walk backwards because you're subtracting a negative. And so you're going to do something like that. Maybe there's some kind of story like that. But clearly kids are going to find that harder than the first two. But it all depends on the model you're using. So if you're using the positive and negative charges kind of approach, then 5 plus -2 involves a bit of cancelling out. So the two negatives cancel with two of the positives. Similarly, the -5 plus 2, it's almost equally easy or difficult to figure out what's going on there. But then the last one, -5 take away -2, effectively you're just doing that. And so if kids are very comfortable with the two-sided counters or whatever you're using for your positive negative, if they're very comfortable with that, it may well be that the one on the right is the easiest of the three. And so asking which is easier or harder really depends on what models students are using. And the idea that you would design a set of questions and then leave it to chance on the day what approach is being taken by the teacher. Perhaps the teacher photocopies a page of questions on negative numbers and then turns up on the day and says, well, I think we'll use number lines, or no, I think we'll use counters. That doesn't seem quite right. Doesn't seem to have the coherence that we're talking about. And so everything depends on the approach, and all the details seem to depend on what kinds of approaches we take. It's actually more subtle than that, because if you think about what we mean by a number line, I've talked about the sort of vector approach and moving backwards and forwards along a number line. But another way to use the number line, say for this one here, -5 take away -2, is to think about distances and difference. So you might say, well, here's -5, here's -2, the gap between them is 3. And so the answer to this is either 3 or -3, depending on which way around it is. And so the kinds of errors students will make will be different depending on the representations. If they're using the number line in that way, they're likely to get plus or -3. So their wrong answer is more likely to be +3. But if they're thinking about walking backwards and forwards, their wrong answer is perhaps more likely to be -7. And so even the errors and misconceptions are going to be related to the methods and representations that we use. So I'm going to end with some tentative conclusions. So a collection of great lessons, individually great lessons, doesn't necessarily make a great collection of lessons. I think I'm clear about that. And so if that's the case, there will be some great lessons for which there's no place in the curriculum that we're designing. So some of our favorite lessons, sadly, may not make it in if we're going to take coherence seriously. I'm thinking quite a bit about the cost of particular representations and methods. When you get to certain topics and people say, oh, there's a nice way to do this, you can draw a table or you can make this kind of diagram, the sort of bespoke things for particular topics. Each of those comes with a cost. It takes some time and effort to get students into those ways of thinking, and that has to be worth it in terms of what the benefit of that is. So there's some representations that are forever, number lines, Cartesian graphs, those are almost part of the content. Kids have to learn those things. And then there are other representations that are just a means to an end, and kids can do them if it's helpful, but they don't need to learn those things necessarily. And so figuring out for that latter category which ones should be in and which ones we might just avoid altogether, that's consuming us a bit at the moment. And then there's many possible sequences that could work. And I think that optimal is not a helpful term, really. We want a sequence that will work, but it doesn't. We don't have to pause everything until we're sure we've got the absolute best one. But I think that the devil really is in the details, and we're seeing that all the time in this work. But I'd love your thoughts and comments, and I'm really looking forward to the discussion that we're going to have together now. Thank you very much.